You've probably seen those massive trucks in movies, the ones that are bigger than a house, hauling tons of rock out of a giant pit. But what if I told you that increasingly, there's no one driving them? That's right, these behemoths are becoming giant self-driving robots. They can see in the dark, navigate with pinpoint accuracy, and even predict when they're going to break down before it happens. Today, we're going to peel back the layers of steel and circuitry to see what makes these incredible machines tick. We'll look at the sensors that act as their eyes, the GPS that gives them their sense of direction, the AI brains that make the decisions, and the network that connects them all into one giant coordinated team. Stick around and watch till the end to uncover the complete technology behind them. Okay, so first things first, if you're going to have a 300-ton truck driving itself around a massive, constantly changing hole in the ground, it needs to be able to see. And not just see like you and I do, but see everything all at once in perfect detail, no matter if it's broad daylight, pitch black, or in the middle of a dust storm. This is where the sensor arrays come in. Think of it like giving the machine a combination of superpowers from all your favorite comic book heroes. They are the eyes, ears, and all-around sensory organs of these autonomous beasts. The first part of this sensory trifecta is LiDAR, which stands for light detection and ranging. This is the cool one. It works by shooting out millions of tiny invisible laser beams every second. These lasers bounce off everything around the truck. Other vehicles, the mine walls, a misplaced rock, and the sensor measures how long it takes for each laser to come back. By doing this millions of times, it builds an incredibly detailed, real-time, three-dimensional map of its surroundings. It's like the truck is constantly feeling its way around the world with millions of invisible fingers, creating a perfect point cloud of its environment. LiDAR units are usually mounted on the roof of the cab or at elevated corners of the truck. Some setups also include LiDAR units on the front corners of the chassis for close-range obstacle detection, but LiDAR isn't perfect. Heavy dust or fog can sometimes interfere with those lasers, so to back it up, these machines also have radar. Radar uses radio waves instead of light. These waves are great at cutting through dust, rain, and snow, so even when visibility is zero, the radar can still detect large objects and their speed. It might not give you that beautiful three-dimensional map like LiDAR, but it provides a super reliable safety net, constantly scanning for big obstacles. Radar sensors are typically installed on the front bumper, rear bumper, and side corners of the dump truck. And finally, you have good old-fashioned high-resolution cameras, just like the one in your phone, but way more rugged. These cameras provide the rich visual context that the other sensors lack. They can see colors, read signs, and identify smaller, more nuanced details. Cameras are mounted in multiple positions, at the front grille or bumper to detect obstacles ahead, at the rear near the dump body for reversing, and along the sides near ladders or wheel arches to monitor close-range blind spots. Many trucks also feature roof-mounted wide-angle cameras that, when combined, provide a 360-degree bird's-eye view. When you combine the precise three-dimensional map from LiDAR, the all-weather reliability of radar, and the visual detail from the cameras, you get a machine with a perception system that is, in many ways, superhuman. It creates a complete, redundant bubble of awareness around the vehicle, which is the absolute foundation for preventing collisions and keeping the entire operation running smoothly and safely. So now our giant robot truck can see everything around it. Awesome. But there's another huge piece of the puzzle. Where exactly is it? Not just generally like your phone's GPS telling you you're on a certain street. I mean, where is it down to the centimeter? In a massive mine where roads are just temporary dirt paths and the edge of a cliff is a few feet away, being off by even a little bit can be a recipe for a very, very expensive disaster. This is where GPS and a technology called RTK come into play, and it's what gives these machines their pinpoint sense of place in the world. Your standard GPS, like in your car or phone, is pretty good. It listens for signals from satellites orbiting the Earth and triangulates your position. But, because those signals travel through so much of the Earth's atmosphere, they get a little distorted, which can lead to an error of a few meters. That's fine for getting you to a pizza place, but it's not nearly good enough for our autonomous haul truck that needs to navigate a narrow path with millimeter precision. To solve this, they use something called real-time kinematic positioning, or RTK. Here's how it works, and it's pretty clever. You have a stationary base station set up somewhere in the mine with a known fixed position. This base station is also listening to the same GPS satellites as the truck. Since the base station knows exactly where it is, it can figure out the precise error in the GPS signal at that exact moment. It then broadcasts this correction data out to all the vehicles in the fleet. The truck's GPS receiver gets the regular satellite signal, and at the same time, it gets this correction signal from the base station. By applying this real-time correction, the truck can instantly cancel out the atmospheric errors and calculate its position with incredible accuracy. We're talking precision down to less than the width of your thumb. This is a total game changer. It allows the truck to know not just which road it's on, but which part of the lane it's in. This level of accuracy is what allows for the perfectly coordinated ballet of machines you see in these mines, where multiple trucks can operate close to each other, docking perfectly with shovels and crushers, all without a human touching a single control. Alright, our truck has super senses to see the world and a hyper-accurate GPS to know its place in it. But, all that data is useless without a brain to process it. This is where the magic really happens, with artificial intelligence and machine learning. The AI is the central command center, the pilot, the navigator, and the mechanic all rolled into one. It's constantly taking in that fire hose of information from the sensors and the GPS, and its job is to make sense of it all and decide what to do next, thousands of times per second. Think about what a human driver does. You're constantly scanning the road, adjusting your speed for traffic, choosing the best lane, and listening for weird noises from your engine. The AI does all of that, but on a superhuman scale. The machine learning algorithms are trained on massive datasets of driving scenarios from the mine. They learn what a normal road looks like, how to react to another truck pulling out, and the optimal speed for a certain grade of hill while carrying a full load. This allows the truck to perform dynamic path optimization on the fly. For example, if the LiDAR detects a newly fallen rock on the planned route, the AI doesn't just stop. It instantly analyzes the data, determines the size and position of the obstacle, calculates a safe and efficient path around it, and seamlessly adjusts its course, all without missing a beat. It's not following a pre-programmed line on a map, it's actively and intelligently navigating a dynamic environment. This adaptive control is what makes the system so robust and able to handle the unpredictable nature of a mine site. But the AI's job goes even deeper. It's also the mastermind behind predictive maintenance. The system is constantly monitoring hundreds of a vehicle's vital signs: engine temperature, tire pressure, hydraulic fluid levels, you name it. The machine learning models are trained to recognize the subtle patterns that come before a part fails. So instead of a truck breaking down unexpectedly in the middle of a haul road, the system can flag it and say, "Hey, my hydraulic pump is showing signs it will fail in the next 48 hours. This allows maintenance to be scheduled proactively, saving huge amounts of time and money. We have our supersensory, hyper-accurate, artificially intelligent robot truck. But in a modern mine, you don't just have one. You have dozens, maybe even hundreds of them. And they're not working alone. You also have autonomous drills, robotic shovels, and automated water trucks. So, how do you get them all to work together as a single, cohesive team instead of just a bunch of individual robots bumping into each other? The answer is the Industrial Internet of Things, or IoT. It's the digital nervous system that connects every single piece of equipment. Think of it like an incredibly robust and high-speed Wi-Fi network that covers the entire mine, which can be dozens of square miles. This network is the backbone of the entire operation. Every autonomous vehicle, every sensor, every shovel, and even the central control room are all connected to it. This constant, real-time data exchange is what enables true fleet management. The central system has a godlike view of the entire mine. It knows the exact position, status, and intention of every single machine at all times. This is what allows for incredible feats of synchronization. For example, the system knows that a specific haul truck is 95% full and will be ready for a trip to the crusher in 3 minutes. It can then look at the positions of all the shovels and other trucks, and automatically dispatch that truck to the nearest available shovel, optimizing the route to avoid congestion. It's like the world's most complex and high-stakes game of air traffic control, but for giant mining equipment, and it's all happening automatically. This connectivity also enables remote diagnostics in operation. If a truck runs into a situation its AI can't solve, a really unusual obstacle for instance, it can pause and send an alert to a human operator in a comfortable control center hundreds of miles away. That operator can then look through the truck's cameras, assess the situation, and either give the truck a command to proceed, or even take temporary remote control to navigate the tricky spot. The IoT is the glue that binds all the other technologies together, transforming a collection of smart machines into a single, hyper-efficient, autonomous organism. So we've seen the lasers, the super GPS, the AI brains, and the invisible network. It's a lot to take in, but when you put it all together, you get something truly revolutionary. Together, these core technologies create a powerful ecosystem, allowing mining machinery to work autonomously with unmatched precision and safety. The LiDAR, radar, and cameras give the machines superhuman senses. The RTK GPS gives them an infallible sense of place. The AI provides the intelligence to adapt and optimize, and the IIoT connects them all into a single, cohesive unit. This isn't just about replacing human drivers, it's about fundamentally redesigning the mining process to be safer, more efficient, and more sustainable. By running 24/7 with optimized routes and predictive maintenance, these systems reduce fuel consumption and wear and tear, and most importantly, they move human operators out of potentially hazardous environments and into safe, remote control centers. It's a huge win for safety and for productivity. It's a perfect example of how we can use engineering and technology to solve really difficult, real-world problems. What we're seeing in mining is really a preview of the future for many other heavy industries, from agriculture to construction to logistics. The principles of robust sensing, precise navigation, intelligent decision-making, and total connectivity are universal. So the next time you see one of those giant trucks, remember all the incredible hidden technology packed inside. It's not just a big truck, it's a glimpse into a future where our hardest, most dangerous work is done by brilliant, tireless robots. Thanks for watching, and I'll see you in the next one.